Hello, this is Calvin the Cow. Wait, this is Professor Calvin the Cow, and today we will be studying steps to build a data warehouse. Now, what is a data warehouse, you wonder? Well, let me explain. In simple words, a data warehouse is a collection of many databases across different stores of the same company. As companies become larger and larger, they have more customers all the time, and for that they have more and more data coming in, and so they need to collect all this information and store it in one single database so that they can service their customers better and do better business. How it works is all these different stores, they collect all their data from all whatever they're selling, and then they send it to the data warehouse where it is brought to a common standard and then integrated so that the chief or the boss can actually view all the company's data in simple terms. So I want to take this opportunity to quickly explain what OLTP and OLAP are. Shazam! Right. So, online analysis process is our data warehouse. We use it less and it handles big data. An online transaction process is our regular database which we use every day. So we use a lot of OLTP and we use less OLAP.
Excuse me, sir.
Yes?
Why do I need a data warehouse? I can always write on paper. Nerd.
Excellent question. Imagine you are the boss of a big company and you're supposed to decide whether some new project is feasible or not. Problem is, you don't have a clue. So, you turn to your records and try to judge from past data. If you had to read through all the paper you wrote on and then summarized it, by the time you make the decision, I would have grown a magnificent long beard, like Dumbledore's. So how do we go along making a data warehouse? Well, we start with, wait, I'm a little thirsty. Right, so what we do first is we actually collect the data, like so. Then we stage and transform the data, bringing it to a uniform format. Why this is important is that all the data needs to be in the same format so that we can apply a single operation to it to make it into a single value. Then we convert the data from the relational model to the dimensional model. Now what that is the relational model is what we use for all our regular databases, which it connects all our data in terms of how they are related. But as data gets larger and larger, the relational model becomes more cumbersome and it's not that good anymore. So we change it to the dimensional model, which is we divide all our data into facts and dimensions. Think of it like a grocery list. I first note down what I have to buy. After that, I can consider all the other things like how many of each item, where to buy from, whether there be discounts or not. So what I have to buy would be my facts, and all the different other things that decide how my facts are affected are called my dimensions. So note that till now we've just designed our warehouse. We haven't actually put any data in yet. Before we put the data in, we'll be doing some pre-processing, which I'll talk about later. So then the next step is to load the data or to populate the warehouse. Now these are just fancy term for a lot of typing. We put in all the information into our dimensional model data warehouse. That's a lot of typing. I usually get Papa Pig and his pig friends to put in that information for me. is to generate the aggregates. Like I said earlier, the boss only wants to see single values that he can easily understand. So, after we've built our data and populated the warehouse, our basic warehouse is done. And then we generate them single values by passing some queries. This process of collecting the data and using it to get some useful information out of it or a pattern is called data mining. It's a really hot topic in the computer industry right now. Now, when you're talking about aggregates, you gotta remember that the more dimensions you have, the more time it takes to make aggregates. Therefore, it's really important to choose where to store your aggregates. And for that, we've got three systems: the relational OLAP or ROLAP, the multidimensional OLAP or MOLAP, or the hybrid OLAP or HOLAP. Now what these do is the ROLAP stores your aggregates in more tables by creating tables. The MOLAP changes your data and your aggregates into more dimensions and stores them like that. And your HOLAP stores data as relational and aggregates as multi-dimensions. Okay then, so now you built your amazingly big and amazingly beautifully designed data warehouse, and you filled in with data and you've been able to generate the aggregates. But you have to realize that you are not the end user of your data warehouse. In fact, you will be the programmer who builds the data warehouse for a client, that is for a company. So you, because you're so awesome and such a genius, you can understand this data warehouse that you have built. But the manager who asked you to build the warehouse may not be able to understand it. So for them, you have to build something called a front end. Now what a front end is an interface, as in it's a screen with different options that access these database from behind, and the user only sees the front. So that's the way to simplify all complex data warehouse transactions and queries and put them into the user's head. Now to build the front end, you can either purchase like ready-made front end or you can build your own. Either way is going to take a lot of time and money, but it's worth it because the data warehouse helps in a lot of analysis and can help the company get more profits. You must remember now that since you are a genius programmer who's building the data warehouse, you have to keep in mind all the different features that you want to put in your warehouse, because your client, when asking you to build a data warehouse initially, will say,
just give me those reports that show me how each portion of the company performs.
And then after you build the preliminary warehouse, he will say,
you didn't get me? I should be able to read from my summary to specific portions, right?
Scumbag. So now I'm going to talk to you about data preprocessing, which I had mentioned earlier. Now what preprocessing is actually the transformation that we do to bring the data into a standard format. You can either do preprocessing at the stage 2, where you bring the data into the data stage, or you can do it just before you populate the warehouse. Either way, preprocessing means to remove noisy, dirty or outlying data that really just interferes with all our good data. So we want to smoothen it out by massaging the data that makes it more consistent and homogeneous for our warehouse. So that's it for my presentation. Thank you for very patiently listening. This is Professor Calvin the Cow signing off.